Newton's first law of motion, or the law of inertia. We call it both ways. You heard of this law many times. Usually, it was not phrased exactly the way I have it written here. Probably you heard it: an object in motion will stay in motion, an object at rest will stay at rest. And that's essentially what we have here, but with a few important qualifiers. First, a moving object will continue moving in a straight line at a constant speed. Okay? That's important. It is a straight line at a constant speed. It's not just continue moving. It will continue moving in the same direction at the same speed. And a stationary object, an object at rest, will remain stationary, will remain at rest. Now, either one of these, motion on a straight line at a constant speed or staying at rest, would change if we act on the object by an unbalanced force. The key here is an unbalanced force. If I have an object that is stationary and I apply two forces at the same time, act on it with two forces at the same time, if these two forces are balanced, it's going to remain stationary. Think about it. This is, for example, a car sitting there at rest, and you come with all of your effort, you push, and it does not move. Why doesn't it move? It's at rest and it does not move. Why doesn't it move? Because the forces acting on it are balanced. There is your push, there is friction, balance in your force, there are also other forces along the vertical. We'll get into that later on. Another example, small cart on wheels, and we have two people pushing one this way, and one this way. Now, if the forces applied by these two people are equal, they are going to balance each other, and the object is going to remain at rest. The same is applicable to moving objects that are moving in a straight line at a constant speed. The other thing that you need to pay close attention to in this case, another point creates difficulty with students, the fact that the moving object will continue moving when we don't have an unbalanced force. What this is saying, if we pay close attention to it, you don't need a force to have an object keep on moving. An object is going to keep on moving at a constant velocity when there are no unbalanced forces acting on it. Which means an object can be moving at a constant velocity with no forces or whatsoever acting on it while it is moving at that constant velocity. It can be moving at a constant velocity when there are two or more forces acting on it that are balanced. Either case, that's all right. The key is to keep on moving on a straight line at a constant speed. It's not going to need a force to keep that motion. So in other words, its natural tendency is to keep moving in a straight line at a constant speed without the need of a force. This is a little counterintuitive. Counterintuitive because we usually, in our common day surroundings, we see objects at rest, and to get them moving, we need to exert a force. But what this law tells us once the object is moving, we don't care how it started moving. But once it is moving, if there is no unbalanced force acting on it, it will keep moving at constant velocity. Now, again, in our common day experiences, once an object is moving, usually if we let it go, it's going to stop. Why is it going to stop? because there are unbalanced forces acting on it, like friction, air resistance, gravity, whatever. So there are forces, there are unbalanced forces that are going to stop it. So in our common day experiences, it's going to be very difficult for us to find cases where an object is going to be free from unbalanced forces. It's going to be very difficult to find those cases. Now, out in the universe, out in space, for example, we don't have that issue. You can have objects move in space subject to no unbalanced forces. Or we can experimentally set up cases where we have unbalanced forces. Okay. Now the key again, a moving object will continue moving in a straight line at a constant speed, and a stationary object will remain at rest unless acted on by an unbalanced force. Now, if we're going to talk about that, one important thing to remember is, what do we define as force? What do we mean when we say a force? I usually ask, whenever we come to this topic, I usually ask, how would you explain a force to a fourth grader or a fifth grader or younger or older? It does not matter. Are you going to be able to explain it graphically, for example, by drawing how a force looks like? The thing is, a force is not a physical quantity that we can describe very easily. A force is a construct that we have used in physics to explain the effects of forces. Now, we talk, for example, and we'll talk later on, of some types of forces like friction, gravity, push, pull, all of these. Electrical forces, magnetic forces, nuclear forces, whatever. In all those cases, we know of the existence of the force because of the effect that it's going to have on the motion of an object. It's essentially going back to Newton's first law of motion. If we see an object changing its speed or changing the direction at which it is moving, then we know there must be an unbalanced force acting on it. That's the way we explain that we have a force. If we see an object speeding up, we know there must be an unbalanced force acting on it. Slowing down, there must be an unbalanced force acting on it. And then we try to explain them by seeing what that object is interacting with. Now, I used the term when we talked about Newton's first law of unbalanced force. What do we mean by unbalanced force? Going back to our card here, if I have someone push it, let's say I'm going to use the unit with a force of 100 newtons. If there is no other force pushing it along that same direction, that force is going to be unbalanced. If instead I'm going to have another person push here, but with a force of 50 newtons. Now, part of that 50 newtons, since this person here is pushing in in the opposite direction, it's going to balance part of this force here. So the unbalanced force is going to be 100 newtons minus 50 newtons, or 50 newtons. Now, if the two forces are equal, my unbalanced force is going to be 0 newtons, or no force. My unbalanced force, in this case, is 50 newtons towards the right. That's what we mean by unbalanced force. We can talk about unbalanced forces when we have two forces, or we can have three forces. Let's assume we have a smaller person here pushing hard at 20 newtons. Now my unbalanced force is going to be 30 newtons, 100 then towards the right, and then I have 70 towards the left. So 30 newtons left, and so on. Now, so the unbalanced force is actually a way to add up the different forces that are acting on an object and find out the portion of the force that's not going to cancel out. That's what we call the unbalanced force. We have other titles that we use for that. Is that needed? I don't know, but we actually use them. One title is what we call a resultant force. A resultant force is exactly the same as an unbalanced force. The resultant force in this case is 30 newtons towards the right. That's what we call resultant. Another term that we use for it is the net force. Again, net force is 30 newtons towards the right. Same kind of idea. The unbalanced force, the resultant, or the net force are all referring to the same thing, the unbalanced force.